Completing the square. What happens if you have a quadratic and it doesn't factor, and you've tried all the methods that we've used, factoring by GCF, grouping, the trinomials in the form ax squared plus bx plus c equals 0, where a equals 1, where a doesn't equal 1, and you've used either grouping or slide and divide. If none of these methods work, we need to try something new. So we're going to talk about a new method called completing the square. The first step is to rewrite the quadratic in the form x squared plus bx equals c. So we want to get all the x terms on the left side, which these are already here, and we need to move this constant over to the other side. So let's subtract 6 from both sides. So those cancel, and we have 3x squared minus 12x equals negative 6. Now, you should notice that that's our first step, getting all the terms with the variables on one side and the constants on the other side. The second step, we need to divide all the terms by a if a does not equal 1. Since we have an a of positive 3, we want to divide every single term by that positive 3. So then we cancel this, and we have x squared minus 4x equals negative 2. And now we're done with the second step in part 1, and we can move on to step 2. We want to complete the square by adding b over 2 squared to each side of the equation. So first let's calculate what that actually is. B is that term, the coefficient of the x, so we have negative 4 over 2 quantities squared. So negative 4 divided by 2 is negative 2, and when we square that, we get positive 4. So we want to add that to both sides of the equation. So we're going to have x squared minus 4x plus 4, and then on the right side we need to add the 4 to the negative 2, which will give us positive 2. And now we've completed step 2. Now in moving on to step 3, we want to factor this left side, the trinomial. Now when we add that b over 2 squared, this is actually a special trinomial where when we factor it, it'll end up in the term x plus b over 2 quantity squared. So when we write that, we have x, and then look at b over 2 right here. Our b over 2 is actually going to be negative 2. So we want to put a negative 2 right there to give us this term. And then we have that quantity squared equals 2. So all we've done is factor the left side of the equation, that trinomial we have. Then we move on to step 4, finding the square root of each side. So this goes back to the method we talked about last time, solving by the square root. So since this squared term is isolated, we can take the square root of both sides, and these cancel out, so we're left with x minus 2 equals, and remember, plus or minus square root of 2. Whenever you take the square root of a number, we always have a positive and a negative answer, so we actually have two options. And since 2 is not a perfect square, we do not want to change that to a decimal, you just leave it as square root of 2. So now we have completed step 4. In our final step of moving on to step 5, solving for x, you should notice that over here, the x is not by itself, and we want it to be isolated. So in order to get rid of this minus 2, we need to add 2 to both sides, and these will cancel out, and we're left with x. Now over on this side of the equal sign, we have a number inside the radical and a number outside the radical. Those cannot be combined. So we're just going to write it as 2 plus or minus the square root of 2. Now this is one way that you can list your answer. What that really means is that x can be equal to 2 plus the square root of 2, and it can be equal to 2 minus the square root of 2. So there are two answers for x. Now I want you to go ahead and try the second example, and then check back with me when you're finished. So when you work this out, hopefully you added 7 to both sides first, and then because our a is positive 1, you don't need to divide through by anything. Then you found that extra term, the b divided by 2 squared, which is going to be 9, that we add to both sides. And then we want to factor the trinomial on the left side to get x plus 3 quantity squared. And now that that squared term is isolated, you take the square root of both sides, and then we have x plus 3 equals plus or minus 4. Now it's nice because 16 is a perfect square, so we have that 4. Then lastly, in isolating the x, we need to subtract 3 from both sides, and then we have the answer x equals negative 3 plus or minus 4. Now since both of these numbers are outside of the radical, we can actually find our two exact answers. Negative 3 plus 4 gives us positive 1, and negative 3 minus 4 gives us negative 7. Those should be your two answers. Now in looking at example 2, I'm going to do a couple steps with you, and then I want you to finish the rest on your own. First, you should notice this x term on the right side by itself. Remember, we want to get all the x terms on one side together. So let's add x to both sides. This cancels, and we have a negative 5x squared, and then plus 10x plus 20 equals 0. And then we need to get this constant on the other side. So subtract 20 from both sides. That cancels, and you have a negative 5x squared plus 10x equals negative 20. Now, remember, before we can actually start with this step, we do have an a that is not positive 1. So make sure you divide through by that a before you find our magic number, add it to both sides, factor, square root, and then find your answers. After you've done that, check back with me and see if you got it right. So once you divide through by negative 5 on each term, you should have x squared minus 2x equals positive 4. Then you can find that magic number, negative 2 divided by 2 squared. So we have negative 1 squared, which is positive 1. Go ahead and add it to both sides. So we have x squared minus 2x plus 1 equals 5. Then you want to factor that left side the special way that we factor. And then when you take the square root of both sides, remember the left side, that squared cancels out, and you have plus or minus square root of 5. Again, remember, do not change it to a decimal if it's not a perfect square. Just leave it in radical form. Then add 1 to both sides, and your final answer should be x equals 1 plus or minus square root of 5. Remember, you can always write your answer as x equals 1 plus square root of 5 and 1 minus the square root of 5. Or you can leave it in the combined answer here. That's it. So make sure to submit any questions if you have any, and then I'll see you in class.